So let's talk briefly about separation of mixtures. How might we isolate pure substances from each other? And so with this, we want to ask ourselves, is this a homogeneous mixture or a heterogeneous mixture? It is easier to separate heterogeneous mixtures. For example, if you have this salad, it's easy to pick apart. I'm going to take out all the tomatoes and move them manually, and the croutons here, and the lettuce here, and the, I don't know, what else do we want in our salad? Edamame goes here, whatever. We can separate those by easy things, those macro scale heterogeneous mixtures. But sometimes we have mixtures that may not be so easy to separate by hand. For example, say we had coffee and water. And by coffee, I mean the grounds. So the actual beans that are insoluble in the water, so they don't go through. How do we separate this? We already do it, right? We go and take that coffee ground mixture. Here it is. We put it all in here through what's called a filter. And out comes our, well, this is really terrible. Okay, let's try this again. I swear I know how a coffee machine works. Ta-da! There we have it. This technique, which we have used all our lives, is called filtration. And in doing so, we're putting a filter to separate things by size. So the coffee grounds, which are much bigger than the water molecules, or the dissolved molecules within the water, are trapped by a filter. So a filter kind of removes large particles. And although both of our lab sections are virtual this semester, this is something that you would do in lab, right? It's pretty easy. You take some sand and water or something, run it through a filter, and you will have separated the sand from the water. So it removes large particles or large bits of matter. So, great. We already know this one. One that we may not be as familiar with, when we actually have homogeneous mixtures then, we have two ways of separating those, relatively speaking. There are more advanced ways that you'll learn in analytical chemistry way on down the road. But for us right now, we have the next one, which is called distillation. And this separates liquids generally from solids or other liquids. If you have liquids that are miscible together, meaning they mixed. So dissolved solids in this case as well. And how distillation works is you will have your homogeneous solution, and we're going to make it blue this time. There it is, it's in here. We're going to heat it up. And as we heat it up, let's see if I can draw a fire. Ugh, that's terrible, isn't it? Okay, well, that's a fire. We'll pretend. Here, we'll make it a little red, too. There, clearly that's a fire. So, as that water heats up, the molecules will vaporize, and we'll do the kind of the old school distillation apparatus. But there are more advanced ones that have cooling and all that. But what is going to happen is our liquid, the water, is going to vaporize. And we're going to end up leaving our solids behind at the bottom once the water evaporates. We're just boiling the water off. But as the water moves along, it can actually start condensing into drops, and out they come, and we can go ahead and collect those in a beaker or whatever we want to collect them in. And after that, we will now have, I'll say pure, water here. So we will have distilled our water, removed all the solid bits from it, and now we have pure water at the end, now that we have distilled it. This is how you also concentrate ethanol. For example, most whiskey, bourbon, vodka, they all kind of start as beers. And you go through the process of distillation, which, as we see here, separates liquids from other liquids, ethanol and water. And although liquids are a bit harder to separate, oftentimes you have to distill multiple times, you can kind of separate the ethanol bit by bit. So maybe the first time you distill it, it's at 12% ethanol. You distill it, it's now at 25%. You distill it again, maybe it's up to 40% now. So by distilling it, you can kind of slowly but surely separate liquids. But solids are very easy to separate. So if you have salt water and boil it, you can get rid of the water, collect it later, and you'll have salt at the bottom of your original flask, which then you can isolate. The last method is the most broad and the most useful, and it is called chromatography. And this is a method you'll employ in organic chemistry. It separates mixtures by polarity. And while it's not something we're going to really go into here because we haven't studied polarity yet, although I guess if you've taken 110, you do know polarity, it separates mixtures by their polarity. So no matter how many components you have in your mixture, if you've got 5 different liquids or solids in there, you can separate them by their polarities. And then you can distill later or something. So this is really a more advanced technique, something that you need a little bit more chemistry knowledge to really work with. But suffice it to say, you run your solution, which is where most of these mixtures are, since they're homogeneous mixtures, you're going to run your solution through a solid that has different affinities for different molecules, polarity. And more polar things will stick on that solid that you're running it through, and things that are less polar will kind of flow along more quickly. And as you go through, you keep putting more and more solution through or solvent, and you start pushing things along slowly, and you end up separating them by their polarity. And this is how most drugs are separated once they're synthesized, how many industrial chemicals are produced as well. This is a very industrially important way to separate things. Because no one wants to buy, an Advil tablet that's not got pure Advil. If it's got like 75% Advil and 25% who knows what as part of the active ingredient, why would you do that, right? You want to make sure your stuff is pure. So chromatography is generally speaking the way to do that, and that's not something we're going to really focus on here. That's more for organic chemistry. And so there we have it. That's how we generally separate mixtures in chemistry, and this is something you will see more in lab. In our next video, we'll talk about energy.